So today let us discuss Introduction to Object-Oriented Programming, and it is commonly known as OOP. This topic forms the foundation for understanding Java, especially the concepts of classes and objects. Before we move into Java programming and memory concepts, it is important to clearly understand how object-oriented programming works and why it is used. First, what is programming? So, programming means giving a set of instructions to a computer to perform a specific task. These instructions are written using programming languages such as C, Java, or Python so that the computer can understand and execute them. In the early stages of software development, programming mainly followed a procedural approach. In this approach, programs were organized using functions, and the focus was on step-by-step execution of tasks. The structure was function-based, where data and functions were kept separate, which worked well for small programs, but became difficult to manage as applications grew larger. So, procedural programming approach. So, here in procedural programming approach, a program is divided into collection of functions. Each function is written to perform a specific task, and the overall programming logic is achieved by calling these functions in a particular sequence. The data used in the program is often shared among multiple functions, which means any function can access and modify the data. Languages such as C and Pascal follow this procedural approach. The main focus here is on writing correct logic and steps to solve a problem rather than modeling real-world entities, which makes this approach less suitable for large and complex applications. Next, limitations of procedural programming. So, procedural programming works well for small applications, but it has several limitations when programs become large and complex. As the size of the program increases, it becomes difficult to manage and understand the flow of functions. There is no proper data security because data is usually shared among many functions and can be accessed or modified from anywhere in the program. Code reusability is also limited as functions are often tightly coupled with specific data. Additionally, real-world problems are hard to represent using only functions and logic. Even a small change in one part of the program may affect the entire program, making maintenance difficult. So, let us move on to what is object-oriented program. So, it's commonly known as OOP, and it is a programming approach that focuses on using objects and classes. So, in this approach, a program is designed by identifying real-world entities and representing them as objects. Each object is created from a class and contains both data in the form of variables and behavior in the form of methods. By combining data and methods together into a single unit, OOP make programs more structured, secure, and easier to understand and maintain. So, why OOP was introduced? So, object-oriented programming was introduced to overcome the drawbacks of procedural programming. As software systems became larger and more complex, managing code using only functions became difficult. OOP provides a better way to organize programs by grouping related data and behavior together. This approach improves security by controlling access to data, increases code reusability, makes program easier to maintain, and allows application to scale efficiently as new features are added. So, let us see a real world example. To understand object-oriented programming clearly, let us take the example of a student. a student has certain data such as name, roll number, and marks. At the same time, a student can perform actions like studying, writing an exam, and viewing results. In WOOP, when we combine this data and these actions into a single unit, it is called an object. So, data along with the action performed on the data together form an object which closely represents real world entities. So, the key features of WOOP, it is built on several important features. The basic building blocks are classes and objects, which we already discussed, where class acts as a blueprint and an object is its real world instance. And next come the encapsulation. So encapsulation helps in binding data and methods together and provides data security. And then inheritance allows one class to acquire properties of another, promoting code reusability. Polymorphism enables the same action to behave differently in different situations. Abstraction focuses on showing only essential details while hiding the internal implementation. We will study each of these in detail in the upcoming topics. Next. So many modern programming languages support OOP approach. Some of the popular are Java, C++, Python, C#, Ruby. These languages allow programmers to create class and objects and implement core OOP concepts such as encapsulation, inheritance, polymorphism, and abstraction. Among these, Java is widely used in academic and industry environments, which is why we focus on Java for understanding OOP concepts. So now the important one. So why Java uses OOP? So Java is a class-based programming language, which means every program in Java is written using classes. All variables and methods are defined inside a class and objects are created from these classes. Java fully supports all the principles of OOP such as encapsulation, inheritance, polymorphism, and abstraction. In addition to this, Java provides automatic memory management through garbage collection, which reduces the burden on the programmer and makes Java program more reliable and efficient. So finally, to summarize, OOP helps us model real-world problems in a simple and effective way. It uses classes as blueprints and objects as real-world representation of those blueprints. OOP makes programs modular, secure, and easier to maintain by organizing code into logical units. Understanding OOP forms the foundation of Java programming and is essential before learning concepts like classes, objects, and memory management in Java. Thank you.
That allows type parameters to be used in classes, methods, and interfaces. It ensures type safety and code reusability by enabling us to define parameterized types instead of using raw data types like object. So it is nothing but instead of creating a class or method or interface